Okay, it's another episode of Dude, why must I flip the inequality sign? You know, less than, greater than, less than or equal to, greater than or equal to. Oh, that is, why must I flip the inequality sign when multiplying or dividing by a negative? This is going to be your classic number explanation. So I'm going to use numbers to explain it. Number explanation. Here we go. Here's something that everyone knows is true. If 7 is equal to 7, that's a true equation. Now, if I add the same thing to both sides, say I add 2 to both sides, 7 plus 2 is 9, and 7 plus 2 is 9. And hey, that's a true statement. Likewise, if I subtract the same amount from both sides, how about 3? If I subtract 3 from both sides, I get a true statement. It's always the case with equations. If I have an inequality, say like 7 is greater than 5, if I add 2 to both sides, 7 plus 2 is 9, and sure enough, 9 is greater than 7. That is true. And conveniently, if I subtract the same amount from both sides, say I subtract 3, 7 minus 3 is 4, 5 minus 3 is 2, and lo and behold, 4 is greater than 2. And this should make sense because what you have here is here's our number line, friendly number line here. And if here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, I'll stop there. In the case of this inequality, I had 7 is greater than 5. Adding 2 just shifts everything 2 over this way. Likewise, subtracting just shifts the 2 dots over. But they always stay in the proper spot with each other. However, let me begin with 7 is greater than 5. If I multiply by a negative, say negative 2, I'll do the same thing to this side. Multiply it by negative 2. Negative 2 times 7 is negative 14. And 5 times negative 2 is negative 10. If I bring this down, hey, negative 14, this is saying negative 14 is greater than negative 10. That is false. And we can see that pretty clearly on a number line. I'll put my 0 right here this time and go negative 1, negative 2, negative 3, negative 4, negative 5. Negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12, negative 13, negative 14, negative 15. Here's negative 10, and here's negative 14, and heck, negative 14 is less than negative 10 on this graph, because negative 14 is less than 10. So when I multiply or divide by a negative number, I have to flip the inequality. When I do, the statement turns into this. Rather than greater than, I'm going to have less than negative 10. And sure enough, negative 14 is less than negative 10. One more example, and then we're gonna end here. Say we have something that includes negatives to begin with. Put a line here to separate what we did. Negative 2 is less than 3. If I multiply both of these, say by negative 5, so I'll multiply negative 5 by negative 2, and I'll multiply 3 by negative 5. So I multiply both sides by the same thing. I have negative 5, and a negative 2 is positive 10. 3 times negative 5 is negative 15. If I kept things the same, it would look like this. But that's false. So I must flip the inequality. And when I do, I get a true statement. 10 is greater than negative 15. Go let it be a part of yourself. This is the closing statement and last word in this episode of Dude, why must I flip the inequality sign? when multiplying or dividing by a negative.